Oh, I guess so I originally called this talk Rocket-Powered Bicycles because I wanted an example of over-engineering. But honestly, that sounds like fun. I don't want a rocket-powered bicycle. Is the clicker thing? Oh, it works. Yep, so this is a little bit about me. This is my four most recent stints. Like I said, I've done everything from IT tech support to freelance development, and now co-founding GroupTie. So have a sort of broad experience. I'm sort of not talking about this as much as like I have the answers, as much as like all the things that I've done wrong and a couple of thoughts on how to avoid them. Little outline of what I'm doing. I'm actually really glad that I went right after Solomon because I feel like my talk dovetails a lot with what he's talking about. I sort of want to talk about like an approach to solving the problem of over-engineering. It's not necessarily going to give you the answer, but it's like how to think about the problem so that we can sort of find that middle ground that everyone wants to talk about. We sort of know the answer is somewhere in the middle, but actually finding what is right for our team and our product and our market is a decision that every single team is going to have to come up with on their own. And the actual doing of that decision is going to, as Solomon said, is a key differentiator. Nadia mentioned I have a degree in physics, so I'm going to talk about this scientifically after I talk about what I think actually product is. And then I'll talk about, if there's time at the end, a few unusual examples of what I think sort of exemplify the approach I'm going to talk about. So the problem. We all know that over-engineering rocket-powered bicycles, although fun, are probably not going to solve your customers' problems, which is how do I get to work with avoiding one-on-one traffic. And we know that, as Solomon was saying, you get into that position where you want to build this huge architecture that can support millions of users when your company's problem is we have no users. So that's the one problem. On the other problem, you have under-engineering, where you overlook major mistakes that the rebels can find in about 10 minutes after receiving your plans. That seems like a fairly major architectural flaw, no matter how many star systems you can blow up. I was just rewatching it. It's amazing how fast they were able to like find that flaw. Like, literally 10 minutes. Like, we found it. We're gonna blow it up. So, and those Ewoks, yeah. So, obviously, we know that over and under-engineering problems are bad. We sort of think this is intuitively, but I want to step back and think of why is over-engineering and under-engineering a problem? Like, why is it always pays to ask questions that seem obvious, because you'll often find out that the answers to that are not as obvious as you think. So I want to talk a little about what product is, so we know why over-engineering or under-engineering it would be bad. This is a great quote I got from one of my friends, Preet, who works at Zynga as a PM. Product is that thing that connects business priorities with user experience. I made it 2 slides, you can't see that because they're the same one. But product is fundamentally the bridge between what your business priorities are, like what you define your market, who you define you're working for, and what the user experience is there. Now you remember I'm a CTO in engineering. If you notice, there's no engineering in that. There's no code. It's not about the code base. It's not about how many servers you have. The product is that experience and how that experience works towards what your business priorities are. So if something doesn't meet your business priorities, it doesn't matter if it's the most beautiful user experience in the world, it's failing as a product. If the user experience is terrible, then it's also failing as a product, even if it might be perfect for your business priorities. So over and under-engineering, I'm going to call it OUE from now on, is a problem because it fails on both of these parts. It fails to realize business priorities because fundamentally the quality of your engineering is not going to dominate the market. Like, it might help you. It's the vehicle that gets you to dominate the market, but it is not itself the market dominant. It's like a race car. Like, the awesomest race car in the world will not win you the race unless you drive it to first place. It also fails to affect the user experience. The users don't really care if your backend is written in Cold Fusion or Node. Your engineers might, but the user does not. And so you need to understand, like, that is always the aim you're trying to do, even when you're engineering. And even as engineers, I think engineers tend to fail at this because they don't talk to users enough. Even when you're doing the engineering, you need to sort of keep this in mind. Okay, so that's the basic thing. The question, of course, is shouldn't we plan for the future? Like, it's all very well and good to say don't over-engineer, don't under-engineer, but you're also not just building for now, you're building for the future. I use some Shakespeare there because fundamentally, product is a story. It's not just where the product is now, it's the whole movement of the idea, the market validation, getting some traction, dominating the market, and finally doing useless patent wars until the end of time, which is, I guess, all of our end game that we want to do. And we need to develop product along that way. Like when you're engineering, you are building for the future. There were several other talks in the road mapping section about how technical debt is a huge problem. That's primarily the problem of under-engineering. When I was freelancing, I met this imaginary guy who I will call Frank. And Frank is an amazing PHP ninja who can build products super fast. And he had built this great feature for this product, and no one could add on a new feature for it. And so they would hire me and say, hey, Chris, we really need you to just add this new feature to this product. I don't understand why no other freelancers can do it as awesome as Frank did it. And I would look at the code base, and it would be, I should have gotten a plate of spaghetti, because that would be essentially the code base. It would just be mush of callbacks and includes, no version control. It would be a disaster. And yeah, Frank was able to move very quickly, but Frank never planned for the future because he was working on contract. He wanted one thing, he got paid, he delivered, and that was good. And when you're building your own product, when you're building your own company, you have to be building for the future, because otherwise you're not building for that story. You're simply building for the present, and when you're building for the present, you're always playing catch up because time is always moving forward. There's a great 10 guy, if you're familiar with Quick Meme, the guy's like super high and he's sitting there thinking, if I want to travel forward in time, all I have to do is wait. And when you're developing, that's what happens. If you're constantly building for the present is always moving forward and you're always falling behind. But you need to be building for the future in such a way that you're not building for the future because you're always shipping in the present. And that's always the problem where you're realizing that value. So sort of approach that I'm going to talk about is how to build enough for the present so that you deliver a product you can actually get out the door, but also build for the future. So we're going to use science because that's what my background is in. This is the scientific method. We all learned it in middle school class. You have an idea and you test it and you come to a conclusion from your test and you go back and do it again. And this is essentially what we're doing in product development, right? I mean, we've talked a lot about getting feedback, getting user metrics, validating ideas. It's applied science. We're all scientists in the applied field of human value interactions, or whatever you want to call people paying you. But fundamentally, you are making a test of, I think that people want this, I will test it, and hopefully they will give me their money and I can retire to Florida. So just as an aside on this, one of the greatest books I've ever read on this thought process moving forward is Thomas Kuhn's The Structure of Scientific Revolutions. It's a relatively easy book for philosophy of science, but it basically goes through much more beyond that sort of middle school idea of how the scientific method works to a detailed historical analysis of how did science actually work and how did it get to the point where we are today. Spectacular read. I've forced my co-founder and everyone else at the company to read it. It was published in like '62, but it was probably like the most important science of philosophy history book written in the 20th century. So I'm sort of going to gloss over the idea section a little bit because fundamentally I'm the engineer, so the idea generally gets given to me. But you have this idea that is about your business priorities. The business priorities are relatively set. You're saying, okay, I think that this particular user experience will positively affect my business priorities. Those business priorities might be onboarding more customers. We think we might be able to get more people if we do this. We might be able to get more traction or more activity if we do this. It's essentially the hypothesis section. And I just wanted to make an aside about this idea. So at a very small company, there's lots of overlap in roles. I'm both the engineer and product and deployment and ops and support and 15 other things too. Engineering and designing a product, I think, are fundamentally different activities that should never be done simultaneously. Engineering is always analytic. It's taking a project and saying, okay, how do I fix this project? When you're designing a product, because you're aiming at user experience, it's a fundamentally empathetic exercise. You are getting into the mind of your user and approaching it from their angle, from their eyes. You need to not let your technical decisions drive your product, which I think actually puts me at odds with another speaker. But definitely some of the mistakes that I've made were building a user interface flow, say an onboarding process, around essentially how I had the database structured. And then I'd show it to an actual user and watch them go through it, and they'd be like, well, why is this here? Like, why am I entering it on 2 different pages? Like, why shouldn't I just fill it out once and just be set up? And the real answer is, well, there's 2 different database tables, and it makes a lot more sense to just make 2 separate queries. They don't care about that. They care about their feel of onboarding. They care about, why is this relevant to me? Why should I waste my time, signing up for your project and going through this process, whatever that aspect of it is. You need to let your product, that user experience and your sort of business priorities, drive the technical decisions you make. Okay, the next part you do is testing. Testing, of course, is the fundamental part. In this particular case, it's the building of the feature. And this is where the famous minimum viable product phrase has been thrown around a lot. I think that's a really good idea. I think it's also been really misunderstood. So I want to cross it out and reverse it, because I think that is the right priorities of MVP, is product, the viable minimum. You never want to build more than the minimum, right? You never want to build too much project. That's over-engineering it. Even if you're Google, there's no point in having 1 billion servers when 1 million servers will do. Your product always needs to be viable. It always needs to solve the problem that it's setting out to solve. It doesn't matter if that problem is a very small problem or a very big problem, it always needs to be viable. And most importantly is the product section. It needs to solve the user experience problem, it needs to solve the business priorities problem. So PVM is what I'm going to use for the rest of the talk on this. This also means very different things at different points in your application. And I think this works not just as the application as a whole, but every individual part of the application. So you could almost say an FVM for a feature viable minimum. Basically the exact same thing applies. The first version of GroupTie was a keynote presentation. We were talking about wireframes. It was literally, here's what we'd like to build. And we'd send it to a bunch of groups, and they said, oh my gosh, that solves a huge problem that I have in terms of organizing my group. At that point in the product development, that was viable for solving the problem that we had, which was validating market. It's clearly not viable today. But it focused on the problem that we were solving. And that's what you need to be focused on. You need to figure out what it is that you're trying to solve so that you can know what level of viability is right for that level. It can't always be minimum, but it can't always be a huge over-engineered mess of code either. So I also want to do this side on scale. You're always going to be, this is always going to be a tension within your organization. How big do we bite off at once? If you always are biting off too little, doing the sort of classic A/B test of well, maybe if we make the button red, it'll be better than if it's blue, you'll probably get to a nice local maximum. At the same time, if you always make big, giant tests, you're also going to be introducing a huge number of bugs. You're going to be not sure if your test actually validated what it is that you're testing. If you put in 30 new features, you don't know which of the features was that actually caused your conversions to go up. I think this is where science actually does give us a really good sort of rubric of how to think about this. Scientists, whether they're dealing with a very well-established theory or a very experimental theory, are always very clear on what exactly is the test trying to prove. Whether you're on the Large Hadron Collider or just doing a little preliminary test in your office, they're always thinking, okay, this is what I want to test with this test. It might be a big idea, it might be a small idea, but we're tailoring the test to figure out if that idea is supported by our hypothesis. And you need to have both, because otherwise you'll end up either biting off too much and making a mess, or you'll end up never moving. Oh, I got cut off there. So the final and most important step, which I think is actually something I'm still learning a lot how to do, is this conclusion and reanalysis. How do you have to sit down after you've done your test and say, okay, did the test actually work? You can't just move on to the next one. This sort of like debriefing phase is absolutely vital to the whole process, because otherwise you're just throwing out ideas and never getting any feedback back. It's like having a conversation where you only talk and never listen for the other person to talk back. Really much more to say other than you really need to do this. So this solves the problem of over-engineering by separating the engineering section, the analytical section, how are we going to solve this problem, from the empathetic question, what is the problem that we need to solve? It also helps us to focus on the next step. I put Occam's razor on there, don't needlessly focus on too many things at once, always focus on a manageable thing you can do with your engineering talent as it is. If it's 100 people, that might be a much different sort of minimum step than if you have 2 people. But at the same time, because you're constantly reevaluating, it prevents you from losing sight of your long-term vision, just sort of squashing little bugs when you could be actually, changing the world. I wanted to use an unusual example of a PVM in Apple, because we normally think of PVMs in terms of, a startup that just threw something out, right? But I think that this process of making the product viably minimum goes all the way up to the useless patent war section of the market. So Apple focuses clearly on the product first, the user experience, and the business priorities. They don't build anything that doesn't have an awesome user experience and doesn't deal with their business priorities. They might be able to build the best video game system out there, something that's been rumored for decades now, but that's not part of their business priorities. They also might be able to build a really great, there's rumors now about the TV, but clearly they don't think that their user experience on that is ready. They also focus on viability second. It just works. That's, once they've decided what they're going to build, making it viable is the second most important thing for them. And the focus on the minimalism third. There is minimalism in Apple. They don't have LTE until several years after every other manufacturer has 4G phones. They don't have art. There's always the things that people complain about that Apple doesn't have. And I really think that that's because they're not going to put something in there until it's ready to ship. Another example actually that I thought of while I was sitting preparing for this, and I want to get out of the technology world for a little bit because I think it's useful to think about non-technology, is In-N-Out, my favorite burger place. So what is their product? Their product is, business priority is, having a really good experience buying burgers, right? So they have a great user experience. You go in there, it's quick, it's fast, it's clean, it's nice, it's very easy to pick out what you want. It's also very viable, it's really quality meat and everything, but it's also minimum. They don't serve chicken, they don't serve wraps, they serve burgers. You have, a regular burger, a cheeseburger, a double cheeseburger, that's all you get. I think that's an example of this approach of focusing on the product, then focusing on viability, and then doing the minimum necessary to achieve that goal without going over or under it. Yeah, that's pretty much it. I can think of probably other examples of this, but I wanted to ask a little time for questions. And if you think of them later, you can ask me via my web presence. So, questions? I floored the room. Yes?
Thanks. So you talked about MVP, and earlier somebody talked about Y Combinator, I think Solomon did. And I feel like there's this sort of feeling that a lot of the incubators are actually causing startups to do the MVP thing to such an extent that they may not actually be able to get to a product in their particular market or their particular product space that is viable enough. Mm-hmm. And I was wondering if you could talk about that as a trend in product development and among startups, if that's a real concern, if it's misunderstood, etc.
I like to be contrary, so yeah, I think it is a problem. I think it's a useful. It's always important to look at solutions to problems in terms of what they were trying to solve in the first place before looking at the problems that they themselves introduced. I think the MVP problem was attempting to solve the problem of startups trying to do too much, like the sort of like, we're gonna dominate everything and be everything to all people, and that's no more of a concrete thing than, you know, I don't know, starting a new religion or something. It's too broad. I think that's what MVP was trying to focus on, fast and iterative. But you're right, I think that and we seriously have really struggled with this at GroupTie, trying to like keep our focus on what we can be and what we should be, rather than, you know, what we can do in the next day or two. And that's why I think it's really important to separate that empathy from analysis, because when you're doing the engineering, you want as small iterations as possible so you can be constantly testing. But when you're doing your vision, when you're thinking about the product, you want to be thinking as long-term and as broad as possible. Yeah. See another question?
I actually have a question. So would you think there might be a conflict between the business priorities and the minimalism? In the sense, like if we go back to your example of the in and out, the business people at some point will say, hey, let's start selling Hollandaise sauce at the counter for 30 cents, it costs us 2 cents, so you have a big business, and then slowly but consistently your product goes down.
I do think that there is a conflict there, but I think it can be a positive conflict. I've heard of the example of that relationship is like a spring. Like if you have like that tension, you know, the engineering department is trying to keep things stable, and the business team is trying to move things forward. And if your spring is too loose, then the company's never going to go, because the business can wander anywhere without actually moving the product. At the same time, if the spring is too tight, then they're just going to drag the engineering team along with them. I think that you want there to be that tension. You want somebody to have vision, and you want somebody to focus on making sure that it's right. That's really why I focus on the minimalism third. Like, minimalism comes after you've figured out what your product is and what's viability. Minimalism is essentially cutting it down to what you need to get it done by the date, essentially. Like, basically, you know, minimalism should be the last thing you think about. Once you've gotten to close to your date and say, okay, what can we actually do by next week and we need to do this, that's when you start cutting things. Up until that point, you should always be focusing on maximizing your product, maximizing your user experience, and maximizing your viability. I see that we're at time.